Hello and welcome back to PC Retro Programmer. In the past few videos we've been taking a look at the CRT controller chip of the IBM CGA card. This is the main chip that's responsible for generating the text and graphics modes of that card, and the chip that's used is the Motorola MC6845 chip or an equivalent. Now in my case I actually have an Hitachi CRTC chip on my IBM CGA card. This is broadly equivalent of course, but in the previous video I was able to demonstrate a number of glitches of the Hitachi CRTC. These glitches were occurring when we set a value in the horizontal displayed register of the CRTC that was greater than or equal to the value in the horizontal total register. This is a condition that's actually warned against in some of the CRTC documentation because it could lead to unpredictable results. But we know that some of this undefined behavior can actually be exploited to get some really interesting effects. Now, at the end of the previous video, I asked a question that I couldn't answer at the time and which I've subsequently figured out, so that's the topic of today's video. And it relates to precisely how these chips work internally. We know that they're very simple chips inside. They just consist of a bunch of counters for counting characters and scan lines and so on, and a bunch of comparators for checking equality of these counter values with the values that we set in the CRTC registers, or perhaps sometimes also other internal counter values. Now all the glitches that we've seen relate to the horizontal displayed value. This controls the number of characters that are actually displayed on the current scan line in the active region before the horizontal blanking begins. So basically there's a counter internally which is counting the characters on the current scan line, and when it reaches the horizontal displayed register value, then some comparator registers this fact and certain events are triggered. In this case, horizontal blanking begins. But we also discovered in the previous video that another event that's triggered by this comparator is the update of the address within video RAM of the start of the next scan line. Of course, this only happens on the final scan line of the current character, but we'd like to know a little bit more about this. For example, that comparator could go high when equality is first achieved, when we're actually at the number of characters that's specified in the horizontal displayed register, and then it could go low again on the next character when equality no longer holds and that value has been surpassed. So which is it? Does the address get updated when the horizontal displayed value is first reached, or does it get updated on the subsequent character when the value is actually surpassed, if there even is a next character? So I've written some code to try and get to the bottom of this, so let's take a look. The code is actually a simple modification of the code we had in the previous video. We change it into CGA mode 4 just as before, and I also fill the first bank with alternating colors, white, magenta and cyan, just as we did before. This is just so we can distinguish all of the characters coming from the first bank. And the second blank is left blank as previously. Then I set the horizontal sync position to 15 once and for all, and as I mentioned in the previous video, you wouldn't normally do this. It gives 2 horizontal syncs for each raster line, but somehow my monitor copes with this. And we also changed the vertical adjust to 3, and I mentioned previously this was just to handle the fact that the frame is actually going to be displayed twice on the screen and we need to keep the correct number of scan lines. So that's all as it was before, and then we come down to the code that's going to allow us to answer our question. I'm going to break each raster line into 2 scan lines as I did previously. The one on the left hand side of the screen is going to have a horizontal total value of 28. Remember, it always adds 1 to that, so it'll be 29 characters wide. And the one on the right hand side is actually going to be exactly the same. So we'll end up with a total of 58 characters per raster line. Now this is one more than you're supposed to have, but again, my monitor handles this just fine. In fact, it gives a perfectly stable picture with these values. And then I'm going to set horizontal display to 29 also in both cases. And because we have 29 characters on each scan line, this means that horizontal displayed is going to be reached each scan line, but not surpassed. And so that's going to allow us to tell the answer to our question, whether that address update occurs if you only reach horizontal displayed and don't surpass it. Now, for those who are playing along at home, you might realize that with a horizontal displayed of 29 on both scan lines, there is no region which is not active. Basically, there's characters being displayed all the way across the screen, and so in fact this polling code stops working and we just end up with whatever values were in the registers. But this is fine because we're not changing them anyway. So this will in fact actually give us a stable picture, and we'll be able to look at that and get the answer to our question. This is the result, and as you can see we've got vertical stripes, and because of the way we've laid the data out inside video RAM, this can only mean that we have the same scan line being displayed all the way down. In other words, the address is not being updated every scan line. So what this tells us is that it's not sufficient for the horizontal displayed value to merely be reached on the current scan line. It must actually be surpassed in order for the address to be updated. So that answers the question that we asked at the end of the previous video.